This is part 2 of Ionic Nomenclature. This is going to cover ionic compounds containing polyatomic ions. So poly is the prefix meaning many or multiple, and so therefore polyatomic means many atoms, and of course ion means that there's a charge involved. So the picture here is showing on the top row monatomic ions, mono meaning one, so this is one atom ions. We have 3 examples. Nitride is just a nitrogen atom with a -3 charge because it gained 3 electrons. Sulfide is a sulfur atom with a -2 charge because it gained 2 electrons. And chloride is one chlorine atom with a -1 charge because it gained 1 electron. Now, these 3 are nonmetals, and nonmetals all create an anion, which is a negative ion. But don't forget that if you have monatomic ions that are metals, they become cations and they become positively charged. Okay, and then also you can figure out what charge they get based on the periodic table and what group they're in. And we'll use that when we name them or coming up with the formula. All right, and then below the monatomic ions are the polyatomic ions, and you can see the difference. The first 2 are nitrate and nitrite, and you can usually tell if it's a polyatomic ion just by the ate and the ite ending. There are some other endings that are used, but for the most part, ates and ites are polyatomic. Nitrate and nitrite have nitrogen in them, okay? And you can tell that the ate has 1 more oxygen bonded to the nitrogen than the ite. Okay, so nitrate is NO3, nitrite is NO2, but they both have a -1 charge. Okay, the next set that we have are sulfate and sulfite. These involve sulfur and oxygen. Sulfate is sulfur with 4 oxygens, so it's SO4, and sulfite has 1 less oxygen than sulfate, SO3, but they both have the same charge, -2. Here's a couple other ones. Ammonium, and that doesn't have an ITE or an ATE ending, but ammonium is the only one that we will be dealing with that has a plus charge, and it's +1. But its formula is NH4 + 1. And then hydroxide, we will be using it a lot, especially when we get to acids and bases and neutralization. But hydroxide is an oxygen and a hydrogen with a -1 charge. Okay, so those are just a few examples. Here is a list of a lot of the common polyatomic ions, and they're grouped by charge. So the first group all have -1 charges, and you have the formula of them and the name. And you can see the formulas, they all have a negative after them. Okay, the next group has a -2 charge, so all the ones in these 2 columns is the formula and name of the -2 polyatomic ions, and then we have -3, and then of course our ammonium, which is +1. All right, and then of course our handy dandy periodic table. So when naming ionic compounds that have polyatomic ions in them, we're going to do the same thing we did with binary. We're going to use their charges and figure out how many of each we're going to need to make a neutral compound. So sodium chromate, sodium is our metal. Chromate is not a nonmetal, it's actually a polyatomic ion. So we got to find sodium on the periodic table, it's right here. Sodium gets a +1 charge, so Na with a plus. And then chromate is polyatomic, and we can locate it on our list, and it is right here. It's CrO4, and it's got a -2 charge. So CrO4 with with a -2. Now looking at the charges, the +1 and the -2, we have to make those cancel out. So we can find the least common multiple of 1 and 2, which would be 2. So you would need 2 sodiums and just 1 chromate. So we reflect that in our formula with subscript 2 behind Na because we need 2 of those. And then chromate, CrO4, there's just 1 of them. We never take the charges and put them in the formula. The formula does not have charges in it. It just has how many atoms we have or how many ions we have in that particular compound. All right, calcium carbonate. Let's use a different color. So calcium carbonate. Calcium is right here in group 2, so it's a +2 charge. And carbonate is right above chromate. So it's CO3 with a -2 charge. So Ca is +2 and carbonate is -2. So looking at those charges, they cancel each other out. So you just need 1 of each. So it's CaCO3. All right, magnesium nitrate, using your periodic table, you would find magnesium in group 2, so it gets a +2 charge, and you could find nitrate on your list. Nitrate is NO3 with a -1 charge. So looking at those, we will need an additional nitrate to make -2. No more magnesium, so just 1 magnesium. So the formula is Mg. And since we have to have 2 nitrates, we have to put the nitrate in parentheses and the 2 outside. So the 2 is telling us we have 2 of everything that's inside that parentheses. Okay, the next one is aluminum sulfate. So aluminum is in group 13, it gets a +3. Sulfate is SO4 with a -2 charge. So looking at these charges, the least common multiple of 3 and 2 is 6. So we're going to need 2 aluminums to make +6 and 3 sulfates to make -6. Okay, so it's going to be Al2SO4 with a 3 outside. And the last one is ammonium chloride. So ammonium chloride, ammonium is not a metal. It's the only polyatomic ion with a plus charge. So it's NH4 with a +1. Now chloride, that IDE ending, tells us it's a non-metal. So chloride is chlorine with a -1 charge. It's a plus and a minus, so they cancel each other out. So you just need 1 of each. So the formula is NH4Cl. Okay, when you do the reverse and you're given the formula and you have to come up with the name, it's a little bit easier. You don't have to really do charges and figure it out. So we have to figure out what the cation is and what the anion is. Potassium is a cation. It's a metal. And that will be our first name. Okay, and then the rest of this is a polyatomic ion. We can go to our polyatomic ion list and look for it. Now, I'll go ahead and tell you that this one is acetate, and acetate can be listed many different ways, but ultimately it is 2 carbons, 3 hydrogens, and 2 oxygens. If you count them up, there's 2 carbons, 3 hydrogens, and 2 oxygens in that. So that is acetate, and you just add it to the name. Okay, the next one is Mg, magnesium. That is a cation, so that's the first word. And then the last part, if you find it on your polyatomic ion list, it is phosphate. So the name is magnesium phosphate. The next one is Al. Aluminum is a cation, is a metal, so aluminum. And then behind it is ClO3, and that is chlorate on your list. The next one, Ca, is calcium. That is a metal, which is a cation, and SO4 is sulfate. And then the last one, Sr, is strontium, and HCO3 is bicarbonate. Okay, one that you might need to pay attention to, okay, say we have this. If you're looking at the first element in this one, nitrogen, that is a nonmetal. That is not going to be a cation. So this is when you would know that you've got the polyatomic ion ammonium, NH4. Okay, so this name would be ammonium. And then behind it is OH. That's another polyatomic ion, hydroxide. Okay, so when you're identifying these, if you end up with a nitrogen first, which should know is not a metal, it's most likely ammonium. All right, that concludes this video, and we'll pick up in the next one on transition metals.